No, you better cut these out.
Good deal.
Welcome to the HACKADAY podcast. My name is Mike Stish. I'm editor-in-chief of HACKADAY.
Hey, I'm Elliot Williams. I'm managing editor of HACKADAY.
This is episode 133. Today we're talking about caustic lenses, not ice cream automation, archery mech suit, and the cheapest robot arm. Elliot, a drone hit a plane
Yeah, I heard about that.
earlier in August up at the Toronto Buttonville Municipal Airport. I bet the person flying that drone is in big trouble.
I would think they would be in big trouble, except
it's the cops. So, first of all, everyone seems to be okay.
Yeah.
The airplane, which was a Cessna landing at the Buttonville Airport, has damage to it, and there's a damage report that you can go look into. But apparently the police were running an operation that was not registered with the traffic control body in the area, which to me I think is very interesting. And Jenny covers this because she's kind of been on that beat where she talked about, drone sightings at Gatwick Airport that were never really substantiated. And because just in general, the hobby of model aircraft kind of getting a black eye or a bad name about this. And then one of the biggest, substantiated problems, plane versus RC aircraft, comes out of a police operation.
hey, stop saying RC aircraft here. It's those darn quad rotors, man. Us fixed wing people are just fine. Yeah, I agree with most of Jenny's take that a lot of this quad panic is really overdone. I actually fly airplanes with wings on them and was out flying mine, and I have a camera set up on it and talking to some random people who were walking by, and they're like, "Oh, you can see what's going on up there?" And I'm like, "Yeah." And the dude is like, "So you're spying on naked women, right?"
Oh, geez.
And you have to imagine me out in the middle of this field, right? It was a really nice sunset, and I was taking really awesome pictures of the sunset over our woods. But there's not a naked person within 50 kilometers. But this is what the public have in their head, is if you're up there with something, you're up to something.
Well, I think the police were definitely up to something on this one.
Yeah, but in this case, they were up to something. And worse, they were flying around an airport without notifying the air traffic controllers, which I guess you could get permission to do that legally.
Oh, yeah.
And they probably should have.
They absolutely should have, 100%. This is why it's ridiculous that we put rules in about not being able to fly a certain distance from the airport, but then here you have someone who should have known better and was doing this in an official professional capacity that are the ones that, get themselves into trouble. And I'm just glad that it didn't go any further than property damage and some headlines in the news.
I saw something in the news this week, and that is that Intel is no longer supporting its RealSense 3D platform. RealSense was a 3D vision with integrated computer in it, in a sensor package thing. It was really fancy and really interesting for people who are into doing robotics with it, because it gives you a 3D view based on cameras. So it's not like a Kinect where it has short infrared range. It's actually line of sight. And now they're discontinued, and the hobby robotics community is wondering what the heck they're going to do now, because it was a slightly expensive but really sweet package.
Yeah, I actually first saw this at the Maker Faire Bay Area, and I'll throw the link in the show notes for that. They had a whole bunch of people that had built stuff to show off this camera. And yeah, it's great for the hobby side of it. But honestly, if you are doing something legit with automation or robots, UAVs, that sort of thing, this was something you could buy that would work. And then it's a software problem from there on out. So I think that it is a loss to see that go away. I have no idea what the adoption rate was for it, but just think about if you were building something and you were using these things, I bet you're trying to buy all the back stock you can find right now.
Yeah, and Intel kind of has this history of floating out projects like this that are really interesting for our group, for the hacker types, and then they don't get as much traction as they want, and then they have to abandon it shortly thereafter. And yeah, this is another one. I don't know what to say. It's Curie all over again.
Well, it's the last piece of news for the top of the show is that there is a new segment of the Hackaday Prize that just launched on Monday. The Redefined Robots Challenge is awesome because I look around and I don't see the robots that we thought we were going to have in the future, like helping us all the time. And so this is a chance to kind of envision what that is. And I would encourage you to go outside of the box on this. So like the butter passing robot, totally legit, right? It passes butter. Like make a bunch of those things. Like nobody's threatened by the butter passing robot. And you're not going to be like, oh, Skynet is upon us. Like that feels like a very reasonable thing. I also think the same thing about like our modern washing machines and dryers that aren't just like electromechanical anymore. You know, like they actually have sensors in there that can dry them efficiently and they kind of know what they're doing. And, you know, some of them connect to the internet. Going along with this, like automation from the software side, like you could make a bot that just watches and makes sure, like I get these horrible headaches when I just work and work and work and I never take a break. And I know like Christina uses those Pomodoro timers to make her get up, and like I just need to get something like that. And if you made it like a personality bot that would pop up, or you know, like that Flight of the Navigator orb eye robot that would like peek up from behind your computer screen and be like, time for a break, Mike. I think that would be an awesome Hackaday Prize entry.
I was thinking something with an arm that would actually come out and poke you and be like, hello.
Your desk chair just slowly tilts until you're standing because it's and then you're like, oh, I better move.
This is a journey into sound.
What's that sound?
What's that sound?
This week we've got not one, not two, not three, but I think 4, maybe even 5 examples of a sound. Have a listen to them and see if you can figure out what they are.
Yes, it's some kind of audio synthesis.
Very good.
Arpeggiations, right? Mm-hmm. Yeah, I mean, I'd go with like a Casio keyboard or something like this, but I bet it's earlier than that.
Yeah, it's differenter.
It's differenter than that. All right, well, I'm excited to see what people will get. I am not going to research this one, but I bet if you poke around, you could figure it out.
So if you know what these sounds were from, let us know. You can find a link to the form where you can submit your answers in the show notes for this episode, Hackaday/podcast.
Hackaday.com/podcast.
Hackaday.com/podcast.
We are on to the first hack this week, and I picked one that Dan Maloney wrote called Math, Optics, and CNC Combined to Hide Secret Images in Acrylic. And this is kind of a mind-blowing demonstration. I really love it. The gist of it is something that looks almost like one of those glass bricks that you would have in a 1974 basement window.
Right.
But it is made of acrylic. You can look through it. It looks like glass. But when you shine a bright light through it onto another surface, it projects an image, and not just an image, but an image in 3 dimensions. So when you move the lens, basically is what this brick is. When you move the lens around, you see an image. And of course, it's the image of a cat. And the best part of this is I had never heard the term caustic patterns before, but it's super cool. If you shine light through a transparent object, you will get a shadow, right? So you'll get like a little bit of, you can tell that it's shining through something. Well, the photons had to go somewhere. And so you would then also get bright points as part of that projection, like in part of that shadow. And that's where the extra photons are. And if you are an absolute optics wizard, like Matt Ferraro is, you can design your lens, I guess, custom lens is what we're talking about here.
Yeah.
In order for those caustic patterns to make images.
Yeah, you can think of this as being like a whole bunch of lenses to make a bunch of bright spots, but then they're all kind of morphed and, jammed together, right? So like the parts of the cat that are light and the parts of the cat that are dark are just the parts where the effective lenses are focusing the light. That's really a great effect. And you look through this piece of acrylic and it's like, that's not a very flat piece of glass. Something's a little bit, it looks like it's kind of a little bit wonky. But then seeing the image, projected onto a piece of paper is really stunning.
So 10 centimeter by 10 centimeter is the size of this one. The surface has a total variation of about 2 millimeters. So like you said, Elliot, it would look like glass that was a little wonky. Or like, the glass that they used to make before they would float it on, now they float molten glass on tin and it flattens out with gravity. So you get like super transparent glass, but it used to be they'd put it on a metal table and let it cool that way, and you get all those waves and stuff in it.
Okay.
Like that's totally what this looks like. So you could install these in a window and you would see out fine, but then when the sun shone in onto the walls, you'd have these shapes. A ton of math goes into this one, which is why it's the first word of the title. But I thought Matt did a great job of explaining this in his write-up. I'm not going to lie. I took his word for it. I did not work anything out myself, and I kind of had to quietly applaud. Another interesting thing is he used the Julia programming language, which is one I've heard of before, but I haven't really seen practical things done in it. So if you're interested in that, look into this. And of course, I'm sure there are people shouting at their podcast devices right now. This is very much like lithophanes. So if you're a 3D printing enthusiast, you can do this with, I believe it's the thickness of the 3D printed material decides whether what's shining through is going to be light or dark. So you can print out something that would be flat on one side and then shine light through it. And that flat part of the 3D print itself is like the projection surface. But this is just so cool with these caustic patterns because the image isn't on the surface of the acrylic. It's actually being projected onto something else.
The part that I thought was astounding about this is how the heck did he make this? And the answer is a CNC machine and then a lot of polishing. And that's the part that I find just physically astounding. Like, sure, you can do all this math and some computery stuff, but at the end of the day, he has to go in with a ball end mill and like carve these lenses into a piece of acrylic and then buff out all of the horrible lines that would have left behind. And what does he say? He did 200, 400, 600, 1,000, and then 1,500 grit sandpapers, and then a soft rag, and then some automotive polish. And this took him, he says he did it in half an hour for this little window, which I don't know. It may only be half an hour, but I know at least when I'm doing that kind of sanding work, it feels like 10 hours.
Yeah, I wondered about the possibility of flame polishing acrylic.
Oh,
because
yeah.
I know some people do that. So I don't know if the surface starting out was soft enough or if it would, warp the lenses too much, but it might be worth a try.
That's actually a great idea. I think you're walking a thin line there, right? Between hitting it too hard and melting it versus doing that. But that's actually an awesome idea. Yeah. Well, keeping up the CNC machine theme, I have beginning the machine shop journey with a DIY CNC. This is a video of a nice CNC mill design from Ryan Kelly. And what I really liked about this is that this is a machine that's designed to be bootstrapped. And he started off with a lot of parts that he could just buy off the shelf that were very precise and got the job done, but then kind of connected them all together with a bunch of parts that he 3D printed. And I think some people in the comments really reacted against this 3D printed CNC mill idea because, well, plastic's just not a good material to make a CNC mill out of. But that's actually the point here, is that Ryan's saying, say you buy kind of decent linear rails and then, he has the thing built on top of a piece of granite and he has some precision cut right angle steel column for the Z and he's bought a nice headstock. He's got nice ball screws. He's spent the money to purchase accuracy wherever he could, but then kind of puts it together with plates that have holes in them that are actually 3D printed and then tests it out. At least in his first video, he gets kind of, mediocre but workable results, which I think is, again, predictable if you're making parts of a machine that's supposed to be strong, but you're making them out of plastic. But he said in the first video when we covered it that he was working his way up, and he's going to then machine the parts out of aluminum to replace the plastic parts that he has in the machine now. So in the end, he's going to work his way toward an all-metal build.
And I mean, I think that makes a lot of sense. We see that all the time. You work to the strengths of your machine and you improve the weaknesses.
Absolutely. And things like lathes and mills are like the original bootstrappable tools. Like, if you have something that can be improved with these tools, these are also the machines that can make the parts to do that improving. And so I thought what was neat is that since we published this article and we're recording this podcast, Ryan has come out with another video where he's replaced 2 of the bigger plastic components and retested it again. And he does find that he gets about a kind of factor of 2 improvement in the stiffness of the machine by swapping them out. He's still got kind of 3,000 of flex when he puts 50 newtons of force on it. So that's about pulling with about 10 pounds of force to you non-metric people. But on the other hand, he can take some pretty deep cuts. He gets really nice looking work done in aluminum, and the thing has improved itself so far. So his conclusion from the second video, as expected, aluminum is better than plastic.
We got to see a real treat coming out of Boston Dynamics last week with a pair of videos for their Atlas humanoid robots. All the headlines everywhere were about the parkour moves that they were doing, which admittedly
that
are
was
awesome.
Really cool.
What are some of the things that they do? Running on like kind of the inside of a curved wall.
Yeah.
Jumping and landing, doing backflips, vaulting over a balance beam, walking on a balance beam, just kind of agile stuff. But what I really loved seeing is the nerd reel, which was them interviewing some of the engineers and technicians that are working on these robots, like while they're in the room working on them, and showing some of the failures of this, like when they blow hydraulic lines on the legs and the things just take a dive. And I gotta say, first and foremost, Elliot, I really appreciate the miracle of the human body when I watch something like this.
Yeah, right? Yeah, like a lot of these jumps are things that you could do pretty easily, but that's because you're really good at balancing.
Right. And, another aspect of why this particular offering is cool, unlike if you remember the dancing that they did, I don't know, last year or whenever it was, the last big one, they actually choreographed that whole dance, and had the robots doing every single thing. This time around, the robots are taking template behaviors, like ideas for how they could balance during a jump and how they could land accurately, and they're applying that to a path that they've been told to go on, but they haven't specifically been programmed for each move on these obstacles. And I think that is really key. But again, going back to the human thing, like we have such an incredible amount of positional data coming into our brains at any given time that, if you want to vault over something and you put your hand on it to vault over it and you set your hand on it just a little bit weird, like your brain will make sure that your hand, wrist, and your arm adjust as much as they can so that you're not going to go, cartwheeling off the other side. And then if you land on your ankle funny, your body will like try and prevent all of the weight from going onto your ankle and further damaging it. And then if you need to like limp off to the side of the stage, like your body just figures out how to do that with the least amount of problems possible. And then it heals itself for a lot of times. Like it's just incredible. And I mean,
take that, robots.
Yeah, this is not the first time that I've thought about this stuff. It just makes me realize how difficult of a problem it is for these robots to do this and how far they've come just to get to this point. And good for Boston Dynamics. I think it's easy to make the jokes about evil robots and Skynet and this sort of thing, but in the end, I think more good will come out of this research than bad, and I think the future is bright for automation.
And if you do not have the champagne budget that Boston Dynamics has to spend on robots, maybe this next hack is more up your alley. This is Minimalist Robot Arm Really Stacks Up. This is a recent project and an entry in the HACKADAY Prize from Norbert Heinz, who runs a YouTube channel under the name Homo Faciens. And he's made some really fantastic CNC machines, including a cardboard prototype machine, and then all the way up to some significantly beefier machines made up with steel rods that can actually cut metal. In this case, he's turning his sights at a robot arm, and it's fantastic. It's made out of scrap wood and basically over a weekend. But what's really clever about the way the arm moves on this robot is that he, instead of using gears or pulleys, he's using a kind of trapezoidy 4-bar linkage type thing. If you can think of the way like a backhoe works, where it's got one solid bar and then it's got that pneumatic cylinder over the top of it that can compress and make the arm lift up. That's basically what's going on here with this arm. What's cool about that is that lets him use screws and stepper motors instead of gears or pulleys or whatever to move the arm around, which makes it easy and cheap to build, especially now that like 3D printer parts are available for a pittance on eBay. That design also gives you the ability to change your design very easily by just making some of the sticks longer, some of the sticks shorter, and that lets you change the leverage for what you want the arm to do. And so this is actually a really interesting and flexible arm design that he doesn't really have plans for because he just kind of winged it when he was putting it together. But the idea is actually flexible enough that you shouldn't need plans. You can follow along with what he's doing and tailor it to, how much weight you want to lift versus how much speed you want to move it around with.
I think it was Ben Krasna who had put out a video that was talking about prototyping, or maybe it was a conference talk somewhere, and just said, just build something. Like, just get something up and running as quickly as you can. And I think that this is an excellent example of it. You could spend the rest of your life planning to build this robot arm, or you could just grab a saw and some 1x3s and start working on this. It's shocking to see how the motors aren't really attached securely like you would normally think about. They're kind of like on a pivot point. Right. And so when they're turning to move the linkage, you can even see the motor kind of moving up and down. They have one of those couplers on them so that it's not like a rigid joint between the screw and the motor. And you kind of see the play that's in there. And you would think that would just make it the thing like horrible with repeatability. But it's the trick that he uses to test this out at the end. He has like a sharpened nail to a really fine point, and then puts down graph paper and like zooms the camera in on it, and then moves the robot arm and tries to move it back to the same place, and he can measure the slop from that, and it's surprisingly accurate.
Yeah, and he gets really good motion in two different directions, which is, I guess, up, and then I'm going to call it Y, and then he gets kind of not such good repeatability in X. And he actually goes through what he did wrong in his design and says, I kind of just winged it on this part, and this part is not strong enough. And here's why. And look, here's the play in it that's making it not so repeatable. And I just love the way he's very frank about these builds and says, look, this part, I kind of half-assed it, but here's what you can learn from the way I did that. And, here's how you need to make it better. I really like that kind of, attitude for the just get a prototype working and then refine it. I just love this build because, again, like you said, Mike, it is something you could do this weekend. If you've got old 3D printer parts kicking around, you can do it with whatever you've got on hand. And as Norbert says at the end of the video, not only does it look cheap, it is cheap. So price shouldn't stand in your way either.
Next up, let's move on to archery, robotic archery, Elliot. Shane Whiten has been running the YouTube channel called Stuff Made Here for a long time. We've looked at a ton of his builds. You may remember the basketball hoop that you cannot miss. Like if you hit the backboard, it will go in because the hoop sees the ball coming and moves the backboard so they can go in. He's done a bunch of other stuff that's been crazy, like an explosive baseball bat. But for me, these auto aiming hacks are really interesting. And in this case, it is a bow, like bow and arrow, that will make sure that you always get bullseyes, even to the point where if the bullseye is moving, you will always be able to get bullseyes. And it does this through the use of a forearm splint, I guess you might call it, that you hold on to instead of holding onto the bow itself. And then the bow is mounted on that splint, and it can move away from you and towards you. And it can also move to the left and to the right in front of you. And then it can tilt up or down. So it's got those 3 degrees of freedom. And then he's using I'm not an archery person, so I would say a trigger device that releases the bowstring and has a servo mounted up to that so that the system can let go of the bowstring when it sees that everything is exactly right. And this is probably the coolest part, Elliot, is in order to see everything is right, you need to have markers. These are like reflective balls on the release mechanism, on the bow itself, and on the target. And then there are high-speed cameras all around him that are pulling in that data, crunching it, and then figuring out when the arrow is precisely angled and taking into account the distance and the amount the arrow will fall while traveling, that it's going to end up at the target that you want.
Yeah, there's a ridiculous amount of computation going on here. And then, like you said, he's basically got the bow mounted on a gimbal mechanism that can do the aiming. And then he's got a trigger that sends the bow flying. Like, I don't even know what the person's doing in this anymore. And I guess he demonstrates that at one point by closing his eyes and, doing the William Tell routine and actually hitting the apple off the mannequin's head. The mannequin's head. This is a family show.
I love it that at some point he's like, wow, holding this out in front of me is kind of tiring and it's heavy. So he puts it on like a camera stabilizer chest rig. Yeah. And I think that, So Danny Conradi in the title here, he called it building an archery mech suit to skip practice.
Yeah, totally.
I thought was apt.
My last hack this week is surprisingly involved for something that seems super simple on its surface. And at least for me, it has completely piqued my interest. This is Occam's Razor Gardening Edition. And this is a project by Kevin Arne to see if he can automate plant watering. And plant watering projects are a dime a dozen. But what he's done here is take the really simplest way you can think of to figure out when the plant needs watering. And that is to put it on a scale. And so when the water evaporates and the plant gets light, you water it some. And then when it's heavy, you know it's full of water, right? Or do you? And this is where this becomes a fantastic project. Kevin's just beginning, but to get this fully working, it's going to have to involve biology. It's going to have to involve, I think, measuring temperature, probably humidity in the room. It's probably going to require learning a whole bunch about strain gauges, probably some statistics, because massaging the data here is going to be as important as anything else. And it's really fun to read through this project and another project, which we wrote up about 6 years ago, wirelessly weighting plants with the ESP8266. And the people who are involved in all these projects getting together in the comments section here. And the things they're worried about are, if you're watering a plant all the time, sure, the water adds weight, but then the plant's growing. And when it grows, it's absorbing some of this water. So you've kind of got a, if you think about a plant growing, it's getting heavier over time. So you got to take that into account with your watering. While this looks like a simple solution on the surface, I think it's actually like an entree into the horribly complicated world of keeping your plants alive.
Well, and as I was looking at this one, I was thinking of the chemistry processes that are going on in the growth of the plant as well, right? So it's taking in carbon dioxide, CO2, and then it's putting out oxygen, O2. So you're missing the C. So you have carbon atoms that are being I don't know, sequestered or incorporated in
Right.
the growth of the plant. So you have the heaviness of it there. I'm not sure what happens to the water. Does the water actually go through a chemical process and become something else, or does it just evaporate out of the plant, do you think?
The water's just evaporating out of the top of the plant. So the plant's slurping the water up, and it's slurping nutrients up out of the soil along
Right.
with the water.
Uh-huh.
And so, this iron and nitrogen, whatever else is in the soil that the plant's slurping up, also becomes part of the new plant growth. That's a wash, though, because that weight was already in the
Right.
pot and it's staying in the plant. But you also mentioned the CO2, and that's what Naira points out in the comments, is that the CO2 is being slurped in from the atmosphere, and all that carbon is adding to the weight of the system. In addition, the plant's bigger, and so it can contain more water all the time as well. And when you change the size of the plant to the amount of dirt in the pot ratio, it's going to change your watering frequency. I think this is a lovely project, and what I'd like to see is a bunch of people doing basically the same thing, collecting the data and sharing it all with each other. Because I do actually think there's something really clever here. And if you've tried those other water sensor things for plants, like the resistance ones or the capacitive ones, my experience with them has been really kind of disappointing. And so I'm looking at this for being a simple solution in a sense, but then you've got to do a bunch of work on the data. So I think this is one of those cases where a bunch of people collecting their data together could make something work for all of us. But let's see.
First up on my list of quick hacks this week, wooden monowheel build is simplicity itself. The Q took it upon himself to build this monowheel, which is like a giant bicycle wheel you sit inside of and pedal from inside, and there's just one wheel, hence monowheel. This one is built out of plywood, a big circle of plywood that is then put together by slats of plywood. And the thing I really liked is that the pedal mechanism is like a wood gear. It's little gear teeth made out of 2x4s that you would pedal, and there's a wood bench with outrunners on the front to keep the thing from tipping over. It's the kind of thing, if you had a very popular restaurant out in the country, you might want to have a couple of these out on the front lawn for people waiting for their meal to pedal around. Next up, modern tape echo made easy. Adam Paul built this device and it sounds wonderful. There is a video of it being used with an electric guitar. It just has a single loop of magnetic tape that is recording what is given on the input. It goes through the loop and it plays it back again before that segment of the tape is recorded over. And the length of that tape is what decides how fast or slow the echo is coming out. If you were reading the HACKADAY newsletter last week and you clicked on this one and the link didn't work, it has been fixed and the project is up again. It was actually Adam wanting to do a better write-up, so he had deleted it because he didn't think anybody was looking at it, but I certainly was. Last up on my quick hacks, Arduino caller ID display is better late than never. This is a project that Dilshan Jayakody built, and it just answers the question in my mind, is there a chip for that? And when it comes to caller ID, indeed there's a chip for that. The HT9032D will look at a landline and pull out all of the caller ID data. I love data hidden in protocols like that, and this is a way that you can try it out if you can only find a landline.
My first quick hack this week is SQLite on the web absurd squill. This is a project by James Long, and it points out the secret underbelly of browsers, which is they're not written super well. In this case, most browsers have a database built into them for storing things you get from the outside world. It's IndexedDB. This is built in most cases on top of an SQLite database. James then implements an SQLite database on top of this IndexedDB database, and he manages to make it run faster than the IndexedDB database itself, even though it's emulated inside of it. He does this with some clever caching, but it makes you think if the browser developers had done any of this cleverness, how much better the world would be. Next up, Hans-Jürgen Grimstad's pint-sized sumo robot is adorable, accessible, and totally awesome. I have a weakness in my heart for sumo robots. These have a line sensor on the bottom so they can see the edge of the ring, and then some proximity sensors so they can find other robots in this ring and push them out. This one's built on a microbit. It uses those nice LiDAR time-of-flight sensors. This video is an awesome design overview. Shows him sketching everything out on paper all the way through to designing the circuit board, getting it printed out, and then having the robots pushing each other around. Lovely, simple robotics build. My last two this week are music and art installations. The first one is by Owen. Interactive musical art installation mixes vintage modern lasers and bubbles. Yes, bubbles. This is his project Auvergne, and basically he has taken a whole bunch of 1980s, 1990s computers, MIDI gear, lasers, a Vectrex, I don't even know how many CRTs, and put them together with a few Raspberry Pis, some Python scripts, and basically taken everything audio-visual that he owns, plugged some synthesizer routines into it, and lets it go. It senses where you are in the room and responds accordingly. This is like a fantastic one-person freak-out rave. And if your tendencies run toward the smaller and more contemplative, Eric Brandal's ESP32 is the brains behind this art installation, is a really nice miniature synthesizer, generative music art project. It has 3 self-playing analog synthesizers that are kind of lightly nudged around by an ESP32. Makes some really sweet music. You should check both of these out.
It's time for the can't miss articles of the week. This is long form content written by our excellent HACKADAY authors. And this week I picked one by Tom Nardi called As ISS Enters Its Final Years, Politics Takes Center Stage. And this one is, I don't know, maybe facepalm, shake my head sort of story. It's kind of sad to see this excellent achievement that is, a workshop in space built by multiple nations come down to some kind of shaky endings here. The station is aging, yet surprisingly to me, it recently just got a new module installed on it, and that was built by Russia. It is called the Nauka module, but as part of installing the Nauka module, the station actually went into a spin. It spun 540 degrees gently but unexpectedly and caused flight control to issue a spacecraft emergency in the middle of this, which has been quite a dust up now between the US and Russia on what went on over this incident.
Yeah, and so it looks like the Nauka, it attached, it got docked, and then it started firing its rockets. And the postmortem seems to suggest that it thought it wasn't docked somehow. This would have been okay-ish if it were in range of the Russian ground stations at the time, but it wasn't, and so it just started firing. Of course, the ISS has other stabilizer rockets that keep its attitude control, and so they were fighting this thing as it was trying to turn the whole ISS around. Satellites and space stations really like to be pointed in the right direction. It makes their radio systems work, it makes their solar cells work, it makes basically everything work. And so this was kind of a scary scene for a little bit. I actually read about this in real time and didn't realize until reading Tom's article that because of the stabilization on board the ISS, it was actually spinning slowly enough that the people on board didn't even really notice it was happening, except, of course, their radios stopped working and, blinking lights. But it wasn't like they were feeling spun out of control or anything.
Right, but it's serious enough that they powered up the Dragon module in case they needed to abandon ship. Interestingly, the modules have been installed by the arm on the space shuttle, which we don't have anymore. And so the ability for this module to, guide itself and get itself lined up and docked is really impressive and an interesting, advancement in the service of the station. You mentioned that it was out of range of the Russian ground stations. That's because the ground control for Roscosmos was the only ones that were able to command the ship. So even though it had docked to the ISS, no one aboard the space station was able to kill the thrusters on it. And the assumption at this point is that the only reason that it stopped firing is actually ran out of propellant.
Well, it's their rocket. They get to drive it.
Well, yeah, I agree, but you should have an e-stop, right?
The Russians don't get to drive the Dragons around.
Right, but you would think that there would be an e-stop for anything that was e-stop is emergency stop, and if you're a roboticist or like things that might cause you physical harm, you have like a hardware brake switch that will like remove power from the motors and stuff. So like if I was doing that with my auto aiming archery rig in the basement, I would definitely have an e-stop on that so that, if someone was walking down range, there was no chance that, anything would happen. So it's a little disconcerting that they had that. Now, since then, the latter part of this title is about politics taking center stage. So now it's just been a finger pointing of like, whose fault is this? Is it the US's fault? Is it Russia's fault? Some old history about problems with the space station has been brought up, and it's kind of devolved into something you just hate to see, like I said at the beginning, and something that is kind of a scientific achievement and a marvel of, working across international boundaries for the sake of learning stuff.
Boy, you want to talk intrigue. My can't miss article this week, Al Williams's freezing out ice cream machine competition, is a deepish look into an issue I didn't really take seriously, which is why the McDonald's soft serve ice cream machines are always out of order. And this has kind of become a goofy internet meme that everybody drives up and they want their like soft serve ice cream and the machine's not working. Some people looked into this and they discovered that one of the reasons anyway is that the machines in question have this fully automatic cycle where instead of changing out the raw ingredients to make the ice cream, they heat it back up to repasteurize it and then cool it back down again. And this cycle takes about 4 hours. But it also seems to be kind of triggered almost whimsically by the machine's brains. And that's where the story gets deeper. And in addition, they have expensive service contracts on these machines, and they occasionally are actually literally broken, and they fire up a service code, and then you have to call the people from Taylor, who makes the machines, to come out and fix it. Where this gets interesting is that a small startup called Kitsch developed a box you can put in the machine that reads the error codes and the status codes and basically diagnoses everything about the machine. It's basically a Raspberry Pi and a web page. But then this lets you yourself diagnose what's wrong with the machine and like head these 4-hour heating cycles off at the pass by just not overloading the machine and stuff. And this led to a fight that's now in court between Kitsch and Taylor, the manufacturer of these machines. And it's really hard to see any good guys in this fight because
that's a good point.
On one side, McDonald's has it in their contracts that the franchises have to use these machines. McDonald's and Taylor are kind of in cahoots economically. And, McDonald's says you have to use this machine. Taylor gets a lot of money from services and going out and fixing these machines. And then Kitsch comes in and is like, here, we'll solve the problem. But the lawsuit is Taylor has picked up one of the Kitsch machines and is reverse engineering it. And Kitsch is claiming that this violates some kind of license agreement that they have, that you can't reverse engineer the device. That, of course, completely raises my hackles, and ironically, they kind of reverse engineered the Taylor device to make their device to interoperate with it. So, hypocrisy there.
Well, I think what Kitsch is saying is that Taylor didn't have permission to own one of these devices. That it was a violation of how they acquired the device. And obviously, if in my mind, what Taylor is doing is they're getting the Kitch device and trying to figure out how to make it so it doesn't work anymore. So they can update the firmware.
They're trying to change their signaling protocol so that it breaks Kitch.
Yeah, and so like I'm always in favor of reverse engineering, but here's a place where the reverse engineering is being used to like further close things off, and that just violates that whole tenet. At the same time, this is the future right here of you have this device and it's got, its own user interface, and it's not entirely easy for everyone to use, and there's a lot of data there that's not making it through to the user. And so someone has come along and made a box that you can plug into it that will put that onto a web interface that you can have on your, or like an app you can have on your phone, that'll get you better logging and better information. Like that act right there is, I think, what we're going to see awesome. A lot happening across the board, in any kind, like we see thermostats doing this, right? It used to be just a thing you had on your wall and you could press a couple buttons and it would give you some numbers. And now they're like internet connected and with all kinds of apps and just a lot more data. We're going to see this added to all kinds of things everywhere. And you don't want to have this kind of like, I'm taking my toys and going mentality from all of these companies, because then we just get tied up in litigation with these things and we don't get an ice cream cone.
And that's all you want at the end of the day. And ironically, the folks running the McDonald's just want to sell you the ice cream cone too, but they have to buy this machine that they can't keep operating. And then when they try to use this second service, the company that makes the device is conspiring against them. It's just, it's a disaster. I just want my ice cream.
That's all the time we have for this episode of the HACKADAY podcast. As always, we'd love to hear from you. You can leave a comment on the show notes, which you'll find at hackaday.com/podcast. You can email us, editor@hackaday.com. We live and die by the tips that you send us, so if you've done something cool or you see something cool, please tell us about it. tips@hackaday.com. And until next time,
keep on hacking. Dun, 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 dun.
It just played. Is there a new sound this week, Elliot?
Yeah, imagine that the theme music just played. No, I'm not going to say that. That whole thing's dumb. It's pretty close to what you think it is, but it's not what you think it is.
Where do I have it?
Is adorable, accessible, and totally something. Crap.
And now on to plants.